Hello everyone, my name is Shubham Kothia and today I'll be performing fine tuning of different LLM using the Unsloth. So as first part, I'll be performing fine tuning a compact model via Unsloth AI. I'll be using small LLM too. So firstly I'll install the Unsloth and different dataset transformer libraries which will be required and also install the Hugging Face to download the model. So firstly I imported all the libraries, then I'll authenticate my Hugging Face and weight and bias tokens. And then after authentication, I'll download the Unsloth small LLM2 135M model from the Hugging Face. Okay, so now model got installed and now it is ready for full fine tuning. And now I'll be performing the loading and preparation of small instruction. So for that, I'll use the dataset Tarsule Alpasa and then I'll split it. And here, this is the prompt I've created. Below is instruction. Describe the task along with input that adds context. Write an appropriate response to complete the request. So instruction will be given, input will be given, and response will be written. So US token, assign the US token, and then prepare the prompt example. So this is the prompt example. Like this is the template. Instruction is give 3 tips for staying healthy. Input none available and response. Eat balanced diet and make sure you include plenty of fruits and vegetables. So this is the example response we got. Now I'll perform the setup of the trainer and then I'll define the training parameter. So for that I will use the SFT trainer, assign the model tokenizer dataset and then assign the arguments here, training argument per device train base size 8 and one step 5 learning rate 1 minus 4 F is 16 and BF 16 and then perform the training here. Here is the training stage and then I'll review the runtime GPU memory uses. So here we can see it uses one GPU, number of example 500, number of epochs 3 and total 189 steps. And then I'll test and the fine-tune model with the simple prompt. So here I send the prompt if the system of equation 3x plus 5 equal to a and 2x plus 5y equal to 2a is a solution when x equal to 2 computer a. So it's a mathematical solution. So it is here written the response. Now I'll save the model here. Model.save pre-trained and tokenizer.save pre-trained. I did save both model and tokenizer and then I'll post it to Hugging Face. Sub 7 small LM to 135 million math. And this is the weight and bias logs. So here initially the training allows reduce a load, then it becomes stable from down 1.07 to maximum 1.29 and then it reduces a lot and then again it becomes stable. So this is the losing pattern it followed during fine tuning. And here I upload it on Hugging Face, Soup 7 small LM to 135 mm. You can check it out and like the model. Now let's move to the second part. So in second part, I'll perform the fine tunings of small LM using LoRa. So install the library and load dataset transformer and Hugging Face out, and then imported the library, authenticated the Hugging Face and bias tokens, and then initialize the small LM to 135 million model, downloaded. And now what is the LoRa adapters here with fast language model dot get pevt model. So assign LoRa rank 16 and target modules is V project, K project, V project and O projection. Get projection, up projection and down projection. and assign the LoRa alpha 16, LoRa dropout 0.05 and bias none. So this is the LoRa adapters assigned, and now set up the prompt here, okay, same as the first assignment, and now I'll perform the fine tuning. So perform the fine tuning. Number of GPU use 1, example 500, epochs 3, total 189 steps. Now testing, write a Python function to check if number is even. So yeah, it is written like even number, check if number is even in Python. And now I'll save this model to Hugging Face, small LM2 135M Alpha LoRa. Now let's move with the part 3. Here I'll perform the reinforcement learning with preferred data, DPO and RLHF. So for that, firstly install the transformer Unsloth and Hugging Face up. Now I'll import the libraries and now load the pre-trained model and then assign the load policy like 4-bit plus LoRa and reference. So here created policy base, assign the LoRa rank 16, LoRa alpha 32, dropout and everything, reference and everything. And then I load the dataset, ultra feedback binarized. So it is a preferred dataset, and then I'll perform the processing of those texts, like truncate the text to chat prompt, convert dream answer, and map DPO. And because it's a feedback dataset, so we have to perform the processing. And then I'll assign the DPO args here, DPO small LM2, DPO RL fast, output directory, and FP16, learning rate 5 minus 6, and then I'll perform the DPO trainer, and then I'll perform the training of the model, and then I'll be saving this. And here I'll test for the inference, like here I'm asking question to fine tune model, explain difference between shallow copy and deep copy in Python with tiny example. In Python, shallow copy is copy of object that is created from existing object, but not from object that is created from copy of exist. If you create shallow copy, here's the example. Provided the example also with the code. So yeah, we successfully completed part 3. Now move to column 4. Here I perform the reinforcement learning with the GRPO, training a reasoning model. So GRPO is a group relative policy optimization, and it's kind of a reasoning model. So I install all the Unsloth dataset and Hugging Face up, ported libraries and authenticated Hugging Face and weight and bias tokens, and then LoRa fine tuning small LM to 135M, and then I'll load the Hugging Face TB small LM to 135M instruct model. Here I loaded it, and then I assign the system prompt like extract goal to message, etc. And then I'll run the norms, exit answer question from message and reward function. Everything is created here. This is the reward function. This is the critical part. And then I'll create the LoRa adapter to GRPO 4-bit base. Created LoRa adapter, and these are the trainable parameters. Then create the GRPO config, and then assign the GRPO trainer, and we then perform the training. Here we can see the training. So initially the reward was 0.01875, and then after training I'll save the model and then I'll perform the inference. This is the system prompt. And here I'm asking question, if a car use 8 liter of fuel to travel 100 kilometer, how much fuel is needed for 250 kilometer? So yeah, it performed the reasoning and then provided the answer. So yeah, we successfully completed the reinforcement learning with GRPU reasoning. And now move to the section 5, which is a continued pre-training using the Hindi language we are using here. So we're gonna teach the LLM new language. So here install the Unsloth and Hugging Face of and everything. Then authenticate the Hugging Face tokens, and then here type data model assigned model language name Hindi. Model we're gonna use Qwen 2 0.5 billion BNB 4-bit model. Then I'll load the Qwen model from the Hugging Face, and then I'll load the dataset. For dataset we are using Alena EC4 with targeted language code again in the mode, and then this is the basic sample text in Hindi. Now I'll get the LoRa adapters here, and the LoRa adapters are 32 LoRa alpha 64, and then perform the continued pre-training with SFT trainer. Here I am performing SFT trainer arguments, training arguments. They assign the data set and packing true. Yeah, this will perform the continued pre-training, and this is the steps we can see. And after that we'll save it, adapters and models, and to inference check we'll do a sample prompting, like here I'll assign prompt संयुक्त राज्य अमेरिका एक विशाल देश है जहाँ, then it will continue, like continue filling the empty lines, like it created second line desk की लोगों को रहने की सुनाई देने का भी विचार है जो. So yeah, we successfully completed qualify continue pre-training using Cohen2 using Unsloth. So thank you everyone.